Hello, my name is Daniel Blacke, and I'm just going to get started. These are the 4 questions for my final demonstration. So here, we're going to start off with the null hypothesis, which is u is equal to 43, which that's our null hypothesis. Then we get our alternative hypothesis, which where it's actually less than 43. Okay. Then after that, we choose our question. Essentially asks us which equation do we want to use, and we use that we're gonna try to find the z-test value. So we use the equation of right here. You can see it right here, z equals x, and all this stuff right here, which we're finding for our z-test value, obviously. So from there, you can see I kind of list the values we have, where it's like x equals 41.5 minutes, n equals 43, sigma's 14, n is 39. And then we essentially from there find that this is a one-tailed test, and then we just sort of plug in our values, which is, you can see me here doing the z-test, but the z-test value, and then just equating it to the value of negative 0.67, essentially saying that, sorry, that's not the end yet. I'm like really tired right now. I'm in pain. Also, just for reference, just to show that I'm not looking at anything weird. I'm just looking at this screen over here. Yeah. Pretty much, from there, we can find our critical value with the significance level, which essentially gives us the critical value of negative 1.28. Which is actually a lower value, so we're failing to reject the null hypothesis theory because it's not in the rejection area, and that's pretty much the first problem done. Second problem is the null hypothesis, which is the mu1 equals mu2, which is and then we get our alternative hypothesis where it's that they don't equal each other. You can see it right here. Yeah, there we go. And then from there, we are, instead of using the z1, we're using the t-test value equation right here, which I'm not going to say, but you can read it right there because it's a whole bunch of stuff, right? And then pretty much we're just plugging in the values that we're given. Like here you can see I have n1, x1, s1, n1, or n2, x2, and then s2, right? So then we're just plugging in that equation right here, which you can see where we're getting our t-test value, which will then give us the value of 5.37, and with there we can do find the degrees of freedom, which is 4.93 divided by 0.008, which then gives us 61.625, which is 61. So then we get a critical value of 1.7, and then negative 1.7 rather. So that's pretty much the second one, because then we can learn there that we're, sorry about this, that we are, that it is in the rejection region, so we are rejecting the null hypothesis. Okay, moving on to question 3. This was the regression line problem, but we start off by finding the correlation coefficient. So here you can see I just start off, because I'm looking for the correlation coefficient, I start off by doing all of these. So right here we have the sum of x, where we're adding all the x values, which you can see I do right here. Then we have the sum of y, which is the same thing, but just the y values. So I'm adding up, getting all the sum of y. Then we have the just the factors of x and y, or like multiplying it together, sorry. So then we get all of those and then add them up. Then we have the sums of x squared, which I add them all up. Sums of y squared, add them all up. And then from there, we just have here, you can see, this is the correlation coefficient equation, which I then plug in. It's kind of long, But okay, wait, yeah, my bad. I plug it in and you can see I drew a little arrow because I went out of whack. I was writing really weird, and I'm bad at writing my notes down, but still. You can see we go down, we apply the entire equation, it's a doozy, and then we get it done, and we get the an R value of -1, so that's our correlation coefficient. And then from there, we're pretty much just calculating, well, we're trying to find y equals ax plus b or y equals mx plus b. We're trying to find the slope. So from there, we just use a equals 5 times 2,422. By the way, these are the values that we found up here. Just to make sure that they don't look made up. These are the values that we calculated and everything. So we're just plugging it in here to find a. And you can see I do that entire equation. And that equates to a -4. So our slope is -4. And then from there, we can find our y-intercept, which is just right here. You can see I wrote down the equation, which is b equals the sum of y minus a times the sum of x divided by n. So that equates to 348 minus -4 times 35.5 equals 98. So then we get y equals -4x plus 98. And there we just have to, for a final step, we're just plugging in the equation it gives us. So it tells us to plug in 12 pretty much for part C. And then we plug in -4 times 12, which equals 48, or -48 rather. So then we add that with 98, and then we get 50, which is our final value. So that's the end of question 3. Okay, now for question 4, we start off with a null hypothesis where it's asking us if it's based on time preference or not. The null hypothesis is not. The alternative hypothesis is based on time preference of the customers, and so here we're using the chi-square test, and then it asks us like how we want to find the value of e, which is like the expected frequency sort of thing. So we use right here, I write it down. E equals k over n, right? Or sorry, n over k. And then from there we solve it. N is 120, and k is just 3. So we do 120 divided by 3, which equals 40. Very easy. And then from there, we're doing our observed frequency, which is O, which is part of the chi-square test equation, because the whole equation is, I wrote it down right, yeah, x squared right here. And you can see it's O minus E squared divided by E. So pretty much we're just doing this over and over again with the values we were given. So you can see for morning I do 20 minus 40 squared divided by 40. And then we do the same thing for afternoon. 30 minus 40 squared minus 40, or divided by 40, not minus 40. And then finally for the evening / night, we do 70 minus 40 squared divided by 40. So then from there we get those those values where it's 10, 2.5, and then 22.5. So we're adding all of those together. And pretty much we get there, we have to find the degrees of freedom, which is just k minus 1, which is just 3 minus 1, and then we get 2. And from there we can find the critical values. Also, I need to say first, once we get, I skip a little bit. Once we add up those values that we got from the chi-square test, once we add up all of those, that gives us our test value, which we can then get, we can see that it's a right tail test. And then pretty much from there, we get a critical value, which shows that it's 5.9, which is like a 6 critical value, which is less, so it's outside of the rejection zone, which essentially tells us that we failed to reject the null hypothesis theory. That it is in the rejection theory. It is in the rejection, sorry. And that we do reject it, because it is in the rejection region. Right. Okay. And that's pretty much those 4 questions. Thank you for a semester of statistics. Have a great Christmas. Merry Christmas.